Troubleshooting a 220-volt 50-amp GFCI on a hot tub involves a systematic approach to identify and resolve the cause of the tripping. Firstly, check the reset button on the GFCI. Make sure it has not been tripped. Push the reset button firmly. If it does not reset, proceed to the next step. Secondly, inspect the GFCI outlet. Turn off the breaker for the hot tub. Remove the GFCI outlet from the electrical box. Check for any loose connections or damaged wires. Tighten any loose connections and replace any damaged wires. Thirdly, test the GFCI outlet. With the GFCI outlet removed from the electrical box, connect a GFCI tester to it. The tester should indicate if the GFCI is functioning properly. If the tester indicates a faulty GFCI, replace it. Fourthly, inspect the wiring to the load. Reconnect the GFCI outlet and turn on the breaker. Use a voltage tester to check for proper voltage at the hot tub. Ensure that all wires are properly connected and insulated. Look for any signs of damage or arcing on the wires. Fifthly, check for water leakage. GFCIs are designed to trip in the presence of moisture. Inspect the hot tub for any leaks or moisture buildup. If water is leaking, locate the source and fix it. Sixthly, check the grounding system. The GFCI requires a proper ground connection to function correctly. Inspect the grounding wire from the GFCI to the ground rod. Ensure that the ground rod is driven securely into the ground and that there is a good electrical connection between the ground wire and the ground rod. If none of the above steps resolve the issue, it is recommended to call a qualified electrician. An electrician can further diagnose the problem and make necessary repairs to ensure the safe operation of the hot tub. Remember to always reset the GFCI after any repairs or maintenance work on the hot tub. Regularly inspect the GFCI and hot tub for any damage or leaks. Do not use the hot tub if the GFCI is tripping repeatedly. When dealing with electrical components, safety is paramount. Always turn off the power at the breaker before inspecting or working on any electrical connections. If you are not comfortable working with electricity, it is best to consult a qualified electrician. Here's a more detailed breakdown of each step. Firstly, confirming the GFCI reset. The GFCI, or ground fault circuit interrupter, is designed to protect against electrical shock. It does this by monitoring the current flowing into and out of a circuit. If there is an imbalance, indicating that some current is leaking to ground, the GFCI trips, cutting off the power. The reset button is a crucial part of the GFCI. When it trips, the button pops out and you need to push it back in to restore power. Sometimes a GFCI trips due to a temporary fault and resetting it is all that's needed. However, if it trips immediately or shortly after being reset, it indicates a more serious problem. Secondly, inspecting the GFCI outlet involves a visual examination and a check for loose connections. Turn off the breaker to ensure your safety. Removing the GFCI from the electrical box allows you to inspect the wiring connections at the back of the outlet. Look for any signs of corrosion, burnt wires, or loose screws. Loose connections can cause arcing, which generates heat and can lead to a fire hazard, as well as nuisance tripping of the GFCI. Tighten any loose connections securely. If you find any damaged wires, replace them with wires of the same gauge and insulation type. Use appropriate wire connectors to ensure a secure and reliable connection. Thirdly, testing the GFCI outlet with a tester is a simple way to verify its functionality. A GFCI tester is a device that plugs into the outlet and simulates a ground fault. When you press the test button on the tester, it should cause the GFCI to trip. If the GFCI trips, it indicates that it is functioning properly. If it does not trip, the GFCI is faulty and needs to be replaced. It's important to use a GFCI tester specifically designed for this purpose. These testers are readily available at most hardware stores. Fourthly, inspecting the wiring to the load involves checking the wires that run from the GFCI outlet to the hot tub. Once the GFCI is reconnected and the breaker is turned on, use a voltage tester to verify that the correct voltage is present at the hot tub. Typically, a 220-volt hot tub will have two hot wires, a neutral wire, and a ground wire. Ensure that each wire is connected to the correct terminal. Look for any signs of damage to the wires, such as cuts, abrasions, or melted insulation. Also, check for any signs of arcing, such as blackening or pitting on the wires or connectors. If you find any damaged wires, replace them with wires of the same gauge and insulation type. Fifthly, checking for water leakage is crucial because water is a conductor of electricity, and even a small amount of moisture can cause a ground fault. Inspect the hot tub for any leaks around the pumps, heaters, and plumbing connections. Also, check for any signs of water buildup inside the hot tub's equipment compartment. If you find any leaks, repair them promptly. Even if you don't see any obvious leaks, moisture can still accumulate due to condensation. Ensure that the hot tub's equipment compartment is well ventilated to prevent moisture buildup. Sixthly, checking the grounding system is essential for the proper operation of the GFCI. The grounding system provides a path for fault current to flow back to the source, which allows the GFCI to trip and cut off the power. Inspect the grounding wire that runs from the GFCI to the ground rod. Ensure that the wire is securely connected to both the GFCI and the ground rod. The ground rod should be driven deep enough into the ground to provide a good electrical connection. Check the connection between the ground wire and the ground rod for any signs of corrosion or looseness. If the ground rod is corroded or the connection is loose, clean the connection and tighten it securely. If the ground rod is severely corroded, it may need to be replaced. Using appropriate tools is important for safety and accuracy. Always use insulated tools when working with electricity. A voltage tester is essential for verifying the presence of voltage and checking for proper wiring. A GFCI tester is needed to test the functionality of the GFCI outlet. A multimeter can be used to measure voltage, current, and resistance, which can be helpful in troubleshooting electrical problems. Wire strippers are needed to remove insulation from wires without damaging the conductors. Wire connectors are used to make secure and reliable connections between wires. Electrical tape is used to insulate and protect electrical connections. Remember, safety is always the top priority. If you are not comfortable working with electricity, it is best to consult a qualified electrician. An electrician has the training, experience, and tools to diagnose and repair electrical problems safely and effectively. They can also ensure that the electrical system is up to code and meets all safety standards. Regular maintenance is also important for preventing electrical problems. Inspect the GFCI outlet and the hot tub's electrical system regularly for any signs of damage or wear. Test the GFCI outlet periodically to ensure that it is functioning properly. Keep the hot tub's equipment compartment clean and well ventilated. Repair any leaks promptly. By following these troubleshooting steps and taking proper safety precautions, you can often resolve GFCI tripping problems on your hot tub. However, if you are not comfortable working with electricity, it is always best to consult a qualified electrician. Furthermore, understanding the specific type of GFCI breaker used for the hot tub is crucial. There are different types of GFCI breakers designed for various applications, and using the wrong type can lead to nuisance tripping or, more importantly, inadequate protection. Check the manufacturer's specifications for the hot tub to determine the correct type of GFCI breaker required. The amperage rating of the GFCI breaker is also critical. In this case, it's a 50 amp breaker, which means it's designed to handle a maximum current of 50 amps. If the hot tub draws more than 50 amps, the breaker will trip. However, the breaker should also trip if there is a ground fault, even if the current is below 50 amps. Ensure that the hot tub's electrical load is within the breaker's rating. If the hot tub has been modified or if additional equipment has been added, it may be drawing more current than the breaker is designed to handle. In such cases, you may need to upgrade the breaker to a higher amperage rating, but this should only be done after consulting with a qualified electrician to ensure that the wiring can handle the increased current. The age of the GFCI breaker can also be a factor. GFCI breakers, like all electrical components, have a limited lifespan. Over time, they can become less sensitive and more prone to nuisance tripping. If the GFCI breaker is several years old, it may be worth replacing it, even if it appears to be functioning properly. When replacing the GFCI breaker, be sure to use a breaker of the same type and amperage rating. Also, follow the manufacturer's instructions for installation. Improper installation can damage the breaker and create a safety hazard. The wiring connections to the GFCI breaker are also critical. Ensure that all connections are tight and secure. Loose connections can cause arcing, which can generate heat and lead to a fire. Use a torque screwdriver to tighten the connections to the manufacturer's specified torque. This will ensure that the connections are tight enough to provide a good electrical contact, but not so tight that they damage the breaker. The location of the GFCI breaker is also important. GFCI breakers should be installed in a dry, well-ventilated location. Avoid installing them in damp or humid areas, as moisture can damage the breaker and cause it to trip. Also, avoid installing them in areas where they are exposed to extreme temperatures, as this can also affect their performance. If the GFCI breaker is installed outdoors, it should be protected by a weatherproof enclosure. This will protect it from rain, snow, and other elements. The National Electrical Code, or NEC, provides guidelines for the installation and maintenance of electrical systems, including GFCI breakers. Consult the NEC for specific requirements related to GFCI breakers in your area. Your local building codes may also have specific requirements for GFCI breakers. Be sure to comply with all applicable codes and regulations. In addition to the steps already mentioned, consider these additional troubleshooting tips. Firstly, check the voltage at the hot tub when it is running. Use a multimeter to measure the voltage between the two hot wires. It should be close to 220 volts. If the voltage is significantly lower, it could indicate a problem with the wiring or the electrical supply. Secondly, check the current draw of the hot tub when it is running. Use an amp meter to measure the current on each of the hot wires. The current should be within the hot tub's rated amperage. If the current is significantly higher, it could indicate a problem with the hot tub's component. Thirdly, check the resistance of the hot tub's heating element. Use an ohm meter to measure the resistance of the heating element. The resistance should be within the manufacturer's specifications. If the resistance is significantly lower, it could indicate a shorted heating element. Fourthly, check the insulation resistance of the wiring. Use a megometer, also known as a megger, to measure the insulation resistance of the wiring. The insulation resistance should be above a certain threshold, typically several megohms. If the insulation resistance is significantly lower, it could indicate damage to insulation. Fifthly, check the grounding electrode system. Ensure that the grounding electrode system is properly installed and maintained. The grounding electrode system should consist of a ground rod or other grounding electrode that is connected to the electrical system. The grounding electrode system provides a path for fault current to flow back to the source, which allows the GFCI to trip. Sixthly, check for any sources of electromagnetic interference, or EMI. EMI can sometimes cause GFCI breakers to trip. Sources of EMI include motors, generators, and electronic equipment. If you suspect that EMI is causing the GFCI breaker to trip, try moving the GFCI breaker to a different location or shielding it from the source of EMI. Seventhly, check for any loose or corroded connections in the electrical panel. Loose or corroded connections can cause voltage drops and other problems that can lead to GFCI tripping. Tighten any loose connections and clean any corroded connections. Eighthly, check for any signs of water damage in the electrical panel. Water damage can damage the electrical components in the panel and cause them to malfunction. If you find any signs of water damage, have the panel inspected by a qualified electrician. Ninthly, check for any signs of rodent damage in the electrical system. Rodents can chew on wires and other electrical components, which can cause them to malfunction. If you find any signs of rodent damage, have the electrical system inspected by a qualified electrician. Tenthly, consult with a qualified electrician. If you have tried all of the above steps and the GFCI breaker is still tripping, it is best to consult with a qualified electrician. An electrician has the training, experience, and tools to diagnose and repair electrical problems safely and effectively. They can also ensure that the electrical system is up to code and meets all safety standards. When working with electricity, always follow these safety precautions. Always turn off the power at the breaker before working on any electrical components. Use insulated tools. Wear safety glasses. Never work on electrical equipment in wet or damp conditions. If you are not comfortable working with electricity, consult with a qualified electrician. Remember, electrical safety is not just about protecting yourself, it's also about protecting your family and your property. By following these safety precautions and troubleshooting tips, you can help to ensure the safe and reliable operation of your hot tub. If the hot tub has a variable frequency drive, or VFD, for the pump motor, that could also be a source of GFCI tripping. VFD can generate harmonic currents that can interfere with the GFCI's operation. If the hot tub has a VFD, try disconnecting it to see if this stops the GFCI from tripping. If it does, you may need to install a line reactor or filter to reduce the harmonic currents. A line reactor is an inductor that is placed in series with the VFD to reduce the harmonic currents. A filter is a device that is designed to block harmonic currents. Both line reactors and filters can be effective in reducing harmonic currents and preventing GFCI tripping. The type of filter that is used will depend on the specific application. Some filters are designed to block specific harmonic frequencies, while others are designed to block a wider range of frequencies. Consult with a qualified electrician or VFD supplier to determine the best type of filter for your application. Surge protectors can also cause GFCI tripping. Surge protectors are designed to protect electrical equipment from voltage spikes. However, they can also leak small amounts of current to ground, which can cause a GFCI to trip. If you have a surge protector connected to the same circuit as the hot tub, try disconnecting it to see if this stops the GFCI from tripping. If it does, you may need to replace the surge protector with a different model or move it to a different circuit. The wiring between the GFCI breaker and the hot tub could be damaged. This could be due to physical damage, such as being crushed or cut, or it could be due to water damage. Inspect the wiring carefully for any signs of damage. If you find any damage, replace the wiring with new wiring of the same gauge and type. Make sure that the wiring is properly supported and protected from physical damage. The hot tub's components could be failing. This could be due to age, wear and tear, or manufacturing defects. If you suspect that one of the hot tub's components is failing, have it inspected by a qualified technician. Some common components that can cause GFCI tripping include the heating element, the pump motor, and the control panel. The heating element can develop a short to ground, which can cause the GFCI to trip. The pump motor can also develop a short to ground, or it can draw excessive current, which can also cause the GFCI to trip. The control panel can also develop a short to ground, or it can send errant signals to the other components, which can cause them to malfunction and trip the GFCI. The type of GFCI breaker used can also affect its sensitivity. Some GFCI breakers are more sensitive than others. If you are having problems with nuisance tripping, you may want to try replacing the GFCI breaker with a less sensitive model. However, be sure to choose a GFCI breaker that is still appropriate for the application. The NEC specifies the types of GFCI protection that are required for various applications. Make sure that you are using a GFCI breaker that meets the NEC requirements for hot tubs. The NEC requires that all hot tubs be protected by a GFCI breaker. This is because hot tubs are located in wet environments, which increases the risk of electrical shock. The GFCI breaker is designed to protect people from electrical shock by quickly cutting off the power if a ground fault is detected. A ground fault is a condition in which electricity flows through an unintended path to ground. This can happen if a wire becomes loose or damaged, or if water gets into an electrical component. When a ground fault occurs, the GFCI breaker will trip, cutting off the power to the hot tub and preventing electrical shock. The GFCI breaker is a critical safety device for hot tubs. It is important to make sure that it is working properly. Test the GFCI breaker regularly to ensure that it is functioning correctly. To test the GFCI breaker, press the test button on the breaker. The breaker should trip, cutting off the power to the hot tub. If the breaker does not trip, It is not working properly and needs to be replaced.